Alright, so here we are with the 8.2 data gathering notes. So hopefully from these notes we'll be able to explain how random samples can be used to make inferences about a population, and then use that probability to analyze decisions and strategies about what to do with that population. So some of the keywords that, we'll start with them because population. So population is the entire group of people or objects that you want information about. So it's your population, what is the set of people or something that we're looking at. Then we have our census, and maybe you've heard of the actual census that went out for the United States, but either way, a survey of an entire population. So they do it every 10 years in the United States, so just asking how many people we are, mostly for breaking down representation of government. So anyway, we have our sample, and the sample is only part of the population. So a lot of times they use this part of the population to represent an entire population because it's too difficult, expensive, time-consuming, whatever it is, to conduct a census, which is why it's only done every 10 years here. So then we have our random sample, and that, of course, usually helps out making things as even as possible, hopefully. But the idea is that every member of a population has an equal chance of being selected for a sample, and random samples are preferred over convenience samples and self-selected samples, etc., which we will go over the types of later. So our next piece here, of course, comes from the fact that now we're sampling, so what happens if our sample is biased? So a biased sample may not be representative of a population. It could, in fact, be underrepresented, or it could be overrepresented. So, for instance, if we took a survey of Avalon students and only asked the 10th graders about whatever it happened to be, that would be an overrepresented population of 10th graders, and of course underrepresented of 9th, 11th, and 12th. So to be specific, underrepresented is one or more of the parts of a population are left out when choosing the sample, and then overrepresented is going to be a greater emphasis, is placed on one or more of the parts of a population when choosing the sample. And again, this happens, either of these, when we're talking about making samples easier to take and things like that, which is why surveys are so difficult, because you want to make sure that you represent populations as well as you can to make any sort of inferences about the data. So that's where these two definitions come in, which is statistics. That's what Chapter 8 here is about. It's a number that describes a sample. So the statistical data says the average age is whatever. And then the parameter is a number that describes a population. So whatever that average age is would have been the parameter. So we've got a little wildlife application here. So a researcher is gathering information on the gender of prairie dogs, excellent, at a wildlife preserve. Why might that be important? Because then you'd be able to make more prairie dogs, hey, or not. So the researcher samples the population by catching 10 animals at a time and recording their genders and then releasing them. So gets 10 animals every once in a while and sees what gender they might be, puts them back up, kind of like mixing a deck of cards, puts them all back out, and then comes back apparently 4 times because we've got 4 samples. So we look at our question here. How can he use this data to estimate the ratio of males to females in the population? Now, some of you may be talking about the legitimacy of this. How do you know that the prairie dogs weren't selected? I mean, I'm sure he went around to different places, whatever it happens to be. But this is our data, and so we're going to be able to, or at least try to make something of it. So if we go ahead and add up each of these columns, for instance, we know that there are 24 males that were caught, and there are 16 females that were caught. And so that means that the ratio of males to females, meaning males colon females, is going to be 24 and 16. But then, of course, we want to reduce that as much as possible. So I'm going to divide by 8, looks like. So if we divide by 8, we're going to get 3 eighths and then 2 eighths. So 3 to 2. So for every 3 males, there are 2 females. There it is. So the next one, it has nothing to do with prairie dogs anymore. So now we're talking about population and the sample of this scenario. So a car factory just manufactured a load of 6,000 cars. The quality control team chooses 60 of those cars and tests the air conditioners. They discover that 2 of the air conditioners do not work. So again, they're not going to test all 6,000 because that is actually the population. They are, in fact, going to take a sample of that, which is going to be 60 cars. And then, of course, 2 would be what we were talking about earlier, with the parameter. So it's talking about kind of what, the statistic would have been 2. But the parameter would have been that because there were, times 100 would have made 6,000. If we times this value by 100, now we get something that represents the population. And so it turns out that they would expect that 200 of them have air conditioners that don't work. Wow, that is a very bad statistic. I'm just going to put 100 cars out there 200 cars out there that don't have working air conditioners. Okay. Anyway. So, let's see. We're going to identify the potentially biased samples here. So, we're going to decide whether each sampling method could result in a biased sample and explain our reasoning. And honestly, depending on what your reasoning is, pretty much everything could be biased. So, just got to figure out how it's being spun. So, a survey of a city's residents is conducted by asking 20 randomly selected people at a grocery store whether the city should impose a beverage tax. I assume they mean alcohol. Okay. Well, this could be interesting. We call this one actually a convenience sample because it's just one grocery store. And what if that grocery store is Aldi? Or what if that grocery store is Whole Foods? I would think that there would be a different set of people at Whole Foods versus Aldi. I don't even shop at Whole Foods. I don't even know where they are. Either way, most likely because of the prices, Aldi is going to have people who have lower income or just like a bargain. And then Whole Foods are going to be either the people that may have more money or that care more about certain types of foods. So on that note, this is a convenience sample, and so it could be biased. It could also, based on location. But it could also be not biased. And this is where you get your argument on. Because what if you were in a small town with one grocery store? this would be an excellent representation. If it takes, like 2 hours to get to the next town, and so this is the only grocery store, pretty much there would be an excellent representation of that town or that city area and what they thought. So, could be either. All right, then we're going to analyze a survey. So a car dealer wants to know what percentage of their population in the area is planning to buy a car in the next year. The dealer surveys the next 15 people who come to the car lot. Are the results of the survey likely to be representative of the population? And I would definitely say no. Maybe there's a way you can spin in the yes, but I'm going to just go with no. Because usually people that are at they don't usually just hang out at car lots unless they're thinking of buying. Now, maybe not. Maybe that is an excellent parking lot and people are using it for a fair that day or something, and so it is representative of like a mass of people. But at this point, people don't usually just hang out at car lots unless they're thinking of buying a car, and so therefore it wouldn't represent the total population of an area. All right, so next one here. In a survey of 40 employees at a company, 18 said they were unhappy with their pay. The company has 180 employees, and we need to predict the number of employees who are unhappy with their pay. So this is where we get to set up a proportion and kind of think of how that might work out. So we have the unhappy sample. And then we have the total sample. And then we're going to have the total employees. Notice those totals are on the bottom. But then on the top, I'm going to have the estimated unhappy employees. So how do we fill that in? Let's see. Unhappy sample, there were 18 of them that were unhappy out of the total of 40 that were surveyed. We don't know how many were unhappy, but we do know that there are a total of 180 employees. So how do we solve this? Cross-multiplying. So we're going to multiply 18 times 180, and that's going to equal 40 times x. What's 18 times 80? So 1,440 is going to equal 40 times x. Divide by 40, and we get an x of 36. So we are going to assume or predict that there are a total of 36 unhappy employees. Why did I get 36 and the answer key got I did 18 times 80. That's a different number. 3,240. That makes it different. 81. Okay. Sweet. And then the last one, the manager of a store randomly surveys 20 customers. Of the 12 staff members, 3 had shifts on the day of the survey. Of the 20 people surveyed, 15 thought the staff were not attentive enough, and the manager decides to close the store for a day and hire a consultant to come in and train the whole staff on customer service skills. Why did the manager make a good decision? Oh, did it? Let's see. So, 20 customers, 15 thought the staff was not attentive. So 15 out of 20 said boo, But then if we look at the number of staff that were there, 3 out of 12 staff, which is only, what is that, 25%? So it's 25% of the staff were said to be 75% inattentive. I assume he estimates then if that a fourth of the staff was, a fourth of the staff there was inattentive, that a fourth of the total staff would be inattentive. But again, that's only 5 out of 20. That doesn't seem like a lot of people. At that point, business-wise, I would have just said no, not a good decision. Just train those that were inattentive. Because why, especially if you were one of the staff that were attentive, that would just be boring to go to an attentive staffing meeting. So training-wise, I suppose I'd take those that are attentive, that I know to be attentive, and make them maybe host sections of the meeting. Anyway, I'm not actually going to be making this happen, but it does seem like not the best decision because it is only a fourth of the staff, and they were 75% not good, I guess. Anyway. Sounds bad. Okay, so anyway, it was only a fourth of the staff. So, no thanks. But again, whatever argument you have, as long as it makes sense, you could probably convince me. So, that's really what I'm looking for on these ones, is just the idea of, did you think about it, and did you look at the numbers and say, oh, well, those numbers are small or large or unrepresentative, something like that. All right. So that is data gathering.